Welcome back everyone to this section on Python object and data structure basics. So in this section of the course, we're going to start off by discussing basic data types. And these are your basic building blocks of code when constructing larger pieces of code. And we're going to quickly discuss all the possible data types that we're going to talk about in this section, and then we'll have lectures that go into a lot more detail about each one. So don't worry about memorizing all the information shown here. This is more just a quick overview, and there's going to be a lecture on each of these data types as we go on throughout this section. So the data types that we're going to be discussing are the following in this table. Here we have the name of the data type on that left-hand column, and then there's the type. So what that means is just Python has an internal keyword for this name, and you're not going to get the whole word integer, the whole word floating point. Instead, Python has kind of a shortened keyword. So that's the second column, such as int for integer, str for strings, etc. Then we have the description column, and that's just going to be what the actual description of the data type is. So let's quickly go through these. We start off with integers, and those are just basic whole numbers, such as 3, 300, 200. Then we have floating point numbers, and those are numbers of a decimal point, 2.3, 4.6, 100.0. And notice here that even if you have 100.0, that still counts as a floating point number. That's no longer an integer because it has a decimal point. Then after that, we have strings, and strings are an ordered sequence of characters. You can think of these as just kind of words, but you should also note they can be numbers as well as foreign characters inside of a string. The main thing that denotes a string is that it either has double quotes or single quotes. Here we can see we have hello in double quotes, Sammy in single quotes. We have the digits of 2000 inside double quotes. That makes it a string. It's no longer just an integer because it has double quotes around it. And then you can also see we have some Japanese characters inside double quotes. Then we come to data structures, and data structures are a little more specialized than basic data types and data objects because they can actually hold data objects in some sort of sequence or in some sort of mapping. So here we have lists, and these are an ordered sequence of objects. Here we can see that we've been able to use square brackets and commas to have a sequence of other objects, such as the number 10, the string hello, and then the number 200.3. Dictionaries are another data structure that can store other data types, except in this case, instead of having an ordered sequence, they have unordered key value pairs. And we'll be discussing in a lot more detail how dictionaries work, but here we can see that we have a key, then a colon, and then a value, and it's denoted by curly braces as far as if it's a dictionary instead of just being a normal list, which has square brackets. But then we can have something like name, and then colon, and then the value of that name is Frankie. Again, we'll be discussing dictionaries in a lot more detail. After dictionaries, we have tuples. Sometimes they're also called tuples. And these are ordered immutable sequences of objects. They look a lot like lists, except they have parentheses, and they're immutable, meaning you cannot change an object that's already in that sequence. So we'll be discussing what immutable means in a lot more detail when discussing tuples. Then we have sets, which are an unordered collection of unique objects. And again, we'll talk about that in a lot more detail. They're a little similar to a dictionary, but they don't have key value pairs. Instead, they're just unique objects in some unordered collection. So you don't have that colon key value pair. Again, we'll discuss it in more detail later on. Then finally, we'll talk about booleans, which are just logical values indicating true or false. Notice how we have capital T and capital F. That sort of syntax is necessary for Python. So those are all the basic data types. Again, don't worry if you didn't understand any of this or didn't want to memorize any of this. We're going to have a lecture on basically each of these topics in a lot more detail and show you how you can use them to write your own code. Okay, let's get started. I'll see you at the next lecture. Hey everyone, welcome back to this lecture on numbers in Python. We already briefly mentioned that there's two main number types that we're going to be working with throughout the course, and that is integers, which are whole numbers, and floating point numbers, which are numbers of a decimal. We're going to be exploring a little bit of basic math with Python, and then we'll also discuss how to create variables and assign them values. Let's open up a Jupyter Notebook and get started. Alright, so before we actually start typing any code, I wanted to briefly mention that if you ever want to toggle this toolbar or this header on or off, you can just come here, click View, and then select Toggle Header or Toggle Toolbar to turn them on or off. And typically, during the lectures, I'll have them off, so we have as much space for coding as possible. Let's start off by just going over some basic math, which is pretty straightforward, and it's basically just using Python as a calculator. If you want to do addition, it's just an addition sign or a plus sign, 2 plus 1. If you want to do subtraction, that's just a dash or a minus sign, 2 minus 1. You can use an asterisk for multiplication, so 2 times 2. And if you want to perform division, that's just a forward slash. So 3 divided by 2 is 1.5. Okay, now let's take a little bit of time to discuss a mathematical operation that you may not have seen before. It's the modulo or mod operator. And basically what this does, it returns back the remainder after a division. For example, if we were to do 7 divided by 4, we get back 1.75. And if you were to do this, kind of using elementary school mathematics, you would say 7 divided by 4, 4 goes into 7 one time with a remainder of 3, because 4 plus 3 is 7. Let's imagine you actually just wanted to know that remainder, the actual number 3. In that case, you can use the mod operator, which is a percent sign. So we're going to say 7 mod 4, and it returns back 3, because 7 divided by 4, it goes in one time evenly with a remainder of 3. So for example, we could do 50 mod 5, and if 5 goes into 50 evenly, then we get back a remainder of 0, which is nice because it's a way to check if a number is evenly divisible by another number. That's a really convenient check when you want to check if a number is even or not. So let's imagine we have an odd number, 23, and we want to know if it's even or odd. Well, I could just look at it, but maybe sometime in my code, it's disguised as the variable, and I really need to quickly check if it's even or odd. One way I could do this is simply with a mod 2. And I know that if mod 2 results in something other than 0, then we have an odd number. Because if I have an even number, then when you divide it by 2, there should be no remainder, or the remainder should be 0. So that's the mod operator. Again, it just gives you back the remainder after you perform a division. Let's continue with everything else about arithmetic. You can also perform powers. So you can do something like 2 to the power of 3. So that's just 2 asterisk signs in a row. So 2 to the power of 3, that's 8. And then we can also perform order of operations. Let's imagine that I have the following equation. 2 plus 10 multiplied by 10 plus 3. If I run that code, I get back 105. But what if I wanted to actually have 2 plus 10 occur first, then multiply that by the result of 10 plus 3? Right now, we're following basic order of operations with math, which is going to perform this multiplication first before it does this addition. So it's performing 10 times 10, 100, plus 2, plus 3. So to have our operations happen first, the way we want them, we can use parentheses. I can say 2 plus 10 multiplied by, and in parentheses, 10 plus 3. And if I run that, I get back 156 the way I want it. Okay, so that's the basics of arithmetic and using Python as a calculator. Hopefully it was pretty straightforward. Coming up next, we're going to expand on this by showing you how you can perform variable assignments. That is to create your own variable name and then assign an object to it. We'll see you there at the next lecture. Welcome back, everybody. In this lecture, we're going to be discussing variable assignments. Now, we just saw how to work with numbers, but what do these numbers actually represent? We had integers and floating point numbers, but we don't actually have a variable name assigned to them. So it'd be nice if we can assign these particular data types a variable name to easily reference them later on in our code. For example, I could say a variable name my_dogs is equal to 2 because I have 2 dogs. Now there are a couple of rules for choosing a variable name in Python, and these rules are that names cannot start with a number. There can also be no spaces in the variable name, so you should use an underscore instead. And you also can't have any of these symbols in a name. And if you accidentally forget this list of symbols, if you were to type one of these symbols out in a variable name, Python would quickly complain and you'd have an error. So you don't need to worry about memorizing all these. You'd get the error as you're typing along. A few more rules about variable names. It's generally considered best practice, according to PEP 8, that names are lowercase. Now there are situations when you become a more advanced programmer where you're going to want to have kind of global variable names in all caps that are used throughout your code. But right now, in general, we'll want to keep all our names lowercase. And we'll also want to avoid words that have a special meaning in Python. And these are built-in keywords like list or str for string. You may be wondering, well, how the heck am I supposed to know what are the special built-in keywords? Luckily, any development environment that's designed to work with Python will have syntax highlighting that will alert you that you're using a built-in keyword by highlighting it a different color. And we'll see an example of that in just a little bit. Before we actually jump to the Jupyter Notebook, though, I want to mention that Python uses dynamic typing. And this means you can reassign variables to different data types. And this makes Python very flexible in assigning data types, and that's actually different than many other programming languages that are statically typed. So let me show you an example of what I mean by this. In Python, something like this is totally okay. Here I've assigned my dog's variable name equal to 2, and then later on in my code, I went ahead and reassigned the same variable name, my dog's, to a completely different data type, a list, Sammy and Frankie. Now that's totally okay in Python, but in other languages that would produce an error, and that's because these other languages are statically typed, meaning in the other language, such as C++, you'd have to say int for integer, and then say my dog is equal to whatever integer value you want, such as 1. And then later on in your code, you would not be able to assign it a different data type. You would not be able to say my dog is equal to Sammy because that's no longer an integer, and that would result in an error. So there are some pros and cons to dynamic typing in Python. The pros is that not having to write out the actual data type saves you a lot of time and makes it really easy to quickly produce Python code. And it also makes your code very readable because you're just reading that variable name. Now, this is kind of a double-edged sword here because the cons is that this may result in bugs for unexpected data type. Because you're not having these restrictions of data types, especially when you're dealing with user input, you may have unexpected data types show up, and that can cause problems later on in your operations. So you should be aware of the data types as you're coding, and you can use the special type function that's built into Python to quickly check the type of any variable. And we'll show you how to use that in just a little bit. All right, let's explore all these concepts by jumping to a Jupyter Notebook. Okay, now that we've seen how to use numbers in Python as a calculator, let's see how we can assign names and create variables. We're first going to create a very simple variable called a and set it equal to 5. And now that I've run that, anywhere in my code, when I call a, it's now assigned the variable 5. And I can reassign it simply by saying a is then equal to something else like 10. And now if I check a, it has 10 there. And I can also add now objects together. I could say a plus a, and that's going to result in 20 because 10 plus 10 is equal to 20. And Python also allows you to do reassignments with a reference to the same object. Let me show you what I mean by that. I could say a, which is still equal to 10. I could reassign it to be, say something like a is equal to a plus a. So what that is saying is take the current value of a, which is 10, and reassign it to a plus a. So that's 10 plus 10. So after I run this, a is now going to be equal to 20. And keep in mind, if I were to run this cell a second time, so notice the in operator here, it's going to go from 40 to 42. If I run a again, it's 40 now. And you can keep doing this again and again, and you'll keep seeing it essentially double each time. So keep that in mind. This is a little different than in a script environment. If you're running a .py script, you won't really see that effect because you'll just have that line once. In a cell environment, you'd have to run that cell over and over again. Okay, so let's imagine that we don't know what type is a. What you can do is use the built-in type function, so that's type, have open and close parentheses, and we'll learn how to create our own functions later on, but pass in the variable there, do Shift-Enter, and you'll get back Python's built-in keyword for what the type is. And in this case, it's int because it's an integer. Let's reassign it to be a floating point number. So we'll say 30.1. Let's check the type of that, type of a, and it returns back that float. So these are the same keywords that we saw when we discussed that table of basic data types. Now, as we previously mentioned, you want to avoid using built-in Python keywords as variable names. And the way you could know if that's happening or not is, let's say I wanted to start assigning int equal to 4. So notice what's happening here. I have syntax highlighting on int, and I didn't get that before with a. So that means that int here is a special built-in keyword, and you shouldn't use it for something like this. So if you ever see that your variable name is having some special highlighting that a normal variable name it doesn't have, then you should avoid using this. So definitely don't ever run that. And if you accidentally ran that as you were following along, or maybe you made some other reassignment mistake, you can always come here to kernel and select restart the kernel, and that will restart the kernel, and it will kind of delete all the variables. So all variables will be lost. So if you ever have some weird kind of error happening because you reassign something like list or int, you can hit restart here. It will restart the kernel, and then you'll need to run these cells again if you ever want to define anything, because if we say a here, it'll say, hey, a is not defined, so you need to rerun these cells, and then you have 5 again. Okay, so last thing I want to note is a simple example where we use variable names. So I will say my income is equal to 100. And then in this cell, I will say my tax rate is, let's say I have a 10% tax rate, so 0.1, and I want to figure out what my total taxes paid are. I will say my taxes is equal to my income times my tax rate. So I have that, and now let's check what my taxes are. How much do I owe? I'll check my taxes, and there I have 10.0. So now I can perform logic with variable names. And this is a lot more readable than just using integers or floating point numbers, because now I have this nice, almost English sentence that says my taxes is equal to my income times my tax rate. Okay, so we've learned some basic numbers in Python, we've learned how to do arithmetic, and we've wrapped it up by learning how to do variable assignment in Python. Up next, we're going to learn about strings. I'll see you there. Welcome back, everyone. In this lecture, we're going to be discussing strings. Strings are sequences of characters using the syntax of either single quotes or double quotes. Here we can see 3 examples. First, we have hello with single quotes, then hello with double quotes, and then what's nice about having both options of single quotes or double quotes, it means that if you have a single quote in your string that you want to keep and not have that end your actual string, you can wrap it in the other type of quote, such as double quotes or vice versa. So here we can see I don't do that, has a single quote in there, but we don't want that single quote to suddenly end the string, so we can wrap the whole thing in double quotes. And we'll see an example of that later on in the Jupyter Notebook. Now what's important to note here is that strings are ordered sequences, and that means we can use indexing or slicing to grab subsections of the string because we know each character has a specific position to be in. And indexing notation, it uses that square bracket notation after the string, or the name of the variable assigned to the string. And we're going to see lots of examples of indexing and slicing in just a little bit. So indexing is the term used when you want to grab a single character from the string. So the way this works is that every single character has an index position assigned to it. So you start at 0. That's another important note in Python, that indexing starts at 0. So H has the corresponding number of 0, E has the corresponding number of 1, L2, L3, O4. So if I wanted to grab the E, what I would use is inside the square brackets, I would pass in a 1 after the string, and then it would return back E. And we'll see examples of that later on. What's also interesting about Python is you can actually use reverse indexing. So maybe you wanted to grab the last letter of a string, but you didn't actually know how long the string was. All you knew was you wanted to grab the last letter. Well, luckily there's reverse indexing available to you, so you can go just grab -1, and it'll grab the last letter of the string regardless of how long that string actually is. Slicing allows you to grab a subsection of multiple characters, otherwise known as a slice of the string. And this has slightly different syntax. Again, it's going to be in square brackets, but because we're grabbing a subsection, we're going to be able to define 3 parts of this. We're going to be able to say start, stop, and step. So again, this goes in square brackets with a colon separating each of these 3 terms. Start is going to be the numerical index of the slice start. Stop is going to be the index you will go up to, but not include. So that's an important note there, and we're going to really focus on that in the examples we'll see in just a bit. And then step is the size of the jump you take from start to stop. Okay, so let's explore all these concepts. They're going to make a lot more sense when we actually see the code examples. Let's hop over to a notebook. Okay, let's quickly show a couple of examples of a string. Again, we can use single quotes, hello, or we can use double quotes. So here I say double quotes with world. You can also have an entire phrase, doesn't need to just be one word. So we can say this is also a string. So we have a whole phrase there, and the white spaces count as characters inside of this string. Now, something we should note here is that we can mix single quotes and double quotes. So if I'm going to say something like, for instance, I'm going on a run. So note what's happening here. Because I'm using single quotes on the outside, only part of this is getting highlighted with the syntax. So this is going to confuse Python because it thinks that you're trying to end the string here, when really I'm trying to end the string here. So if I try to run this cell, it'll say an error here, invalid syntax. What I really want to do is wrap this in double quotes, and that way I won't have an error when I have this single quote in here. So then when I run this, Python has no problem. It says, okay, I get what you're trying to do here, trying to have a single quote there stay, and that's actually not part of the definition of the string. So now let's discuss actually printing out a string. So far, we're actually just asking the string to be returned. And that's the reason we see in and out with these cells. And that's also the reason we actually see the quotes in the output below the cell. But we can use the print function to actually print out a string. So we're going to say print hello. And if we run this, note what we actually get back. We no longer see the out in the cell, and instead we no longer see the quotes themselves. We're actually just printing out the actual string. And the reason this is important is because let's imagine I wanted to say hello world 1, and then I also wanted to say hello world 2. If I were to run this, what ends up happening is I only get back that last string. In order to see everything, I actually have to print out the results. So I will say print, and wrap this in parentheses, print hello world 1, then I'll say print, and then say hello world 2. And then when I run this, I get to see both strings printed out. So I no longer see that output, I'm actually just printing the results. Now something else I want to mention is that there's actually escape sequences, and escape sequences allow you to kind of have special commands inside of your string. So let's just go ahead and say print hello world, and if I run this, I see hello world printed on one line. But I can actually add an escape sequence, so it's going to be a \n, and what this does is it basically tells Python, hey, this n right here, that's no longer the character n. I actually want you to, because of this backslash, treat this as a new line. So if that escape character there, it's going to say print hello, space, then a new line, and then space world. So that's what we see here, hello, space, and world. If I wanted world to be lined up with hello, I could actually just touch it like this, run that, and then I see hello world. And Python knows not to include this letter n there because it's essentially attached to that backslash. So another popular escape sequence is T for tab, and if I run that, I get back hello, tab, so 4 spaces, world. And we'll be talking a lot more about this when we discuss print formatting coming up next. For now, another built-in function that I want to show you is the len function, or the length function. So this allows you to check the length of a string. So I can say hello, and if I run this, I get back length of 5 because there's 5 characters in that string. If there happens to be a space in the string, so I will say I am hungry. Let's make it more obvious. We'll just say I am. And we run this. Here we can see there's 4. So we have I space am, so that counts as a length of 4 characters in the string. All right, we'll stop it here for now, and in the very next lecture, we'll pick up right where we left off, discussing string indexing and string slicing. I'll see you there. Welcome back, everybody. In this lecture, we're going to continue right where we left off last time, but we'll be discussing string indexing and slicing. Indexing, where we grab a single character, and slicing, where we grab a subsection of that string. Let's jump to the Jupyter Notebook and get started. Okay, so to start this all off, I'm going to create a variable called myString, and I'm going to set it equal to the string hello world. So notice there's a space in there between hello world. I run this, and let's check to make sure. Okay, so we have hello world there, ready to go. Now, let's imagine I wanted to grab a single character from this string. In that case, I want to use indexing. So what we do is we call the variable name, we have square brackets off of it, and let's imagine I want to grab the first character, that is capital H, then I pass in a 0, because indexing starts at 0, and that allows me to return that first character, H. Let's try to grab another character. Let's say we want to grab R, so let's count this out. MyString, and we want to count from 0, so that's 0, 1, 2, 3, 4, 5, so notice the space counts, 6, 7, 8. So if I pass an 8 there, it should return R. Perfect. So again, this is known as indexing. Now let's imagine we wanted to grab this letter L. Well, there's 2 ways I could actually do this. I could say myString at 9, because that's right after that R. The other way I could do it is using the reverse indexing we previously mentioned. So starting at 0 from h, I can go backwards in the string so that d is -1, and that means this L is -2. So if I say my string -2, I will actually get back that L. And then if I keep going backwards in the string, I'll get back that R, which is right before the L. So I will get back this R right there. So you can use both positive index positions and negative index positions to grab elements or characters from the string. And that's really useful again because oftentimes you'll have a variable string, maybe it's someone's name, and you don't know how big that name is, but for whatever reason you want to grab the last letter of their name, then you can always just use -1, and you know that's the last letter of the string. Okay, let's go ahead and continue to discuss slicing. So slicing is a little more complicated because we're grabbing a subsection of the string. So that's more than one character typically. Let's review our string. Oops, my string here is hello world. And I'm going to redefine my string, just so this is a little easier to follow, as A, B, C, D, E, F, G, H, I, J, K. So just kind of a string of the alphabet there. We'll redefine it. And now I have this string of the alphabet. So let's imagine that we wanted to grab a subsection of a string that started at a particular index and then went all the way to the end. Well, the way we could do that is we would say my string, square bracket notation, and then we would say the starting index, let's imagine we want to start at the letter C and then go all the way to the end. So C is at index 2 because it's 0, 1, 2. So what I do is I pass in 2, and if I just do that, it gives me back the letter C. But if I want from C all the way to the end, I can say colon, and that indicates starting at index 2, colon, go all the way to the end, and there we have CD all the way to K. Okay, now let's imagine kind of an opposite situation where I want to grab everything up to a particular index. Then I could say my string, colon, and let's say I wanted to grab A, B, and C. So starting at the very beginning, go ahead and grab all the way up to essentially letter D here. So we'll say 0, 1, 2, 3, pass in 3 there, and then we run this and we get back A, B, C. Now this is sometimes confusing for students because if we check out my string, technically we have the D at index position 3 because it's 0, 1, 2, 3. What you should note here is that the stop index, this term right here for 3, which only returns back A, B, C, that stop index is basically saying go up to, but not including that index position. So go up to the letter D, but don't include it, which essentially says A, B, C. So keep that in mind as you're kind of playing around with slice notation. This stop is up to, but not including. Okay, let's combine these two ideas of a starting index and a stop index by trying to grab a subsection of a string that's in the middle. For example, let's try to grab D, E, F from the middle of the string. The way we can do that is we say my string, open square brackets, and then we start off with our starting index position. In this case, it's at letter D, so that's 0, 1, 2, 3. Then we say colon, and then it's going to go up to the index position of G here, because I just want D, E, F, so we're going to go up to, but not including G. So that's 0, 1, 2, 3, 4, 5, 6. And now if I run this, I get back D, E, F. So let's practice this one more time by trying to grab another subsection of the string. For example, let's try to grab just B and C, these two letters, B, C. So the way we can do that is we'll type out my string, open and close square brackets. Our starting index position is at 0, 1 for B, colon, and then it looks like we want to go up to, but not including D, so that's 0, 1, 2, 3. We'll run this, and there we have BC. And I would encourage you to try to grab a subsection. So choose a subsection of the string and then see if you can grab it. You can go ahead and pause the video and try that out. Okay, to end our discussion, let's quickly discuss step size. Let's imagine that I wanted to grab everything from the beginning of the string all the way to the end. Well, technically, that's just the string itself, but I could also use colon notation for this. I could say colon, colon, and that basically says from all the way to the beginning, go all the way to the end. Now, you don't often see this because you might as well just call the string itself, but this is technically valid syntax. The reason you might see something like this is if someone wanted to specify the third parameter, and that is the step size. So right now we're saying go all the way from the beginning to the end in a step size of 1. A, B, C, D, E, F, G. So that's the default step size of 1. However, I can change that by providing a number such as 2, and that says go in jumps of 2. So from A, go to C, to E, to G, to I, to K. So if I run this, I get back A, C, E, G, I, K, because I'm jumping in a step size of 2. We can increase this to be a step size of 3, and then we'll get from A, jump to D, jump to G, jump to J, and then there's no more letters to jump to because we're jumping in a larger step size. So that's how step size works, and you can combine this with a start and stop as well. So we could say something like starting from index 2, go up to but not including index 7 and a step size of 2, and we get back C, E, G. So C, then jump to E, then jump to G. So notice how this all works in combination. You have a start, a stop, and then a step size. Something that you may commonly see is using a clever step size trick to reverse a string. And what you can do is say my string, and then say from all the way to the beginning, all the way to the end, take a step size of -1. And what that does is it actually reverses your string, because you're saying from all the way to the beginning to all the way to the end, go and take a backward step, which is then K, J, I, all the way to the end. So this is kind of a little Python trick. Often in interviews, people ask you to reverse a string, and they kind of get annoyed by Pythonistas because they quickly just do this nice kind of slick one-liner instead of doing a for loop. But I just want you to be aware of that. Typically in our code, we won't really be using this too much because it's more of a trick, but again, a very useful one at that. Okay, so that's it for slicing and indexing. Coming up next, we're going to discuss a little bit about some useful string properties. We'll see you there. Welcome back, everyone. In this lecture, we're going to finish off our discussion about strings by talking about string properties and string methods. Let's jump to a notebook and get started. The first thing we're going to discuss is the immutability of strings. And immutability, it stems from the word mutate, basically means immutate, or you cannot mutate or cannot change. I'm going to show you an example of this. Let's create a variable called name and set it equal to Sam. Now let's imagine we want to change this name to Pam, so change the S for a P. Well, you may think that you would do something like this. Say name, index at 0, and then just set it equal to P. Now for strings, unfortunately, you can't do this. If you try to run this code, you'll get an error because strings are immutable, meaning a string object or str object doesn't support item assignment. So you can't grab one of these characters, one of these elements in the string, and then try to reassign it this way. Strings just don't work that way in Python. Later on, we'll learn about other data types that do support item assignment. All this means is that if we do want to reassign this S to be a P, we basically have to create a new string. And we can do that with concatenation, that is kind of merging two strings together. So I'm going to comment this out, and to create a comment, you just put a hashtag in front of it. And if you run this, you won't get anything out. So basically anything with a hashtag is just commented code that doesn't get run. Let's explore this example of trying to create the string Pam using what we already have about name. So the first thing I want to do is try to grab A and M. So let's use the slice notation that we learned about earlier. We're going to start at index 1 and then go all the way to the end. So let's check that. Okay, so that's AM, perfect. So we'll assign this to something like last letters is equal to name 1 all the way to the end. So then if I take a look at last letters, again I can use tab to autocomplete here. It says AM. And now what I can do is I can concatenate P to last letters. And the way you do that is with the plus sign. So we can say P plus last letters, and then we get Pam. So this is known as string concatenation. Let's explore a couple more examples. I'm going to say X is equal to hello world, and then I could say X plus it is beautiful outside. And then if I run this, I can see hello world, it is beautiful outside. Something to keep in mind is note that there's no space here because there was no space at the end of world and there's no space at the beginning of it. So what would be nice is if you add a little space there, so when you run this again, hello world, it is beautiful outside. Now if I do this multiple times with a reassignment, so I could say X is equal to X plus it is beautiful outside, Now when I run this, I've redefined x, so I can see now, hello world, it is beautiful outside. If I accidentally ran this cell more than one time, I'd add in it is beautiful outside a second time. So if I run this again, notice how my in numbers are going to change right next to the cell. Now it says, hello world, it is beautiful outside, it is beautiful outside. And we could keep doing this, and you keep adding it on. So this is string concatenation, and it allows you to quickly put strings together. There's also multiplication you could do to kind of do multiple string concatenations at once. Let me show you what that looks like. So far we've used a plus sign to kind of concatenate two strings together or merge them together. But if you had the letter equal to z, and you quickly wanted 10 z's, what you could do is say letter times 10, and there you could see essentially someone sleeping here, z, 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 10 times. So that's using multiplication with letters, and then that's using a plus sign with letters. Something to keep in mind when you're performing string concatenation or string multiplication is that you're going to get errors if you try to concatenate a number with a string. I want to show you what I mean by that. Imagine we're doing 2 plus 3. If we run this, we get 5. That makes sense. If we do 2, the string 2 plus the string 3, now that they're strings, it's not going to add them together. Instead, it's going to perform concatenation. So here now we get back the string 23. And this is a callback to dynamic typing where we had to be really careful about the data types. So keep this sort of problem in mind that your user may end up putting in strings, and then later on in your code, if you start adding them together, you may end up with an unexpected result like 23 instead of 5. So this is a really prime example of both the good and bad of Python's ability to be very flexible. So it's very flexible, meaning you're not getting an error here, but maybe it's a little too flexible because you expected 5 and it gave you back 23. Later on, we're going to learn about a lot more ways that we can kind of prevent these sort of mistakes or errors. Let's continue on by discussing some built-in string methods. So objects in Python usually have built-in methods, and these methods themselves are essentially functions that are inside the object. And later on, we're going to learn how to create our own functions and our own methods. For right now, we'll go over just a few useful methods. I'm going to create a new string. Let's call it x and say it's hello world. And if I hit x dot and then hit tab, I should see this list pop out in the Jupyter Notebook. And this is a list of all the attributes and methods that are available on this string object. Now again, make sure you've already defined x, otherwise you won't see anything. So make sure you ran that cell that says x hello world, and then in a new cell say x dot, hit tab, and you should see this list. So as you can see, there's tons of methods here, and we're not going to go over all of them right now. We're just going to go over the most useful ones that you'll be using later on in this course. So to quickly uppercase everything in a string, you can say dot upper, open and close parentheses, and it will uppercase everything in the string. Keep in mind, this method is not in place. That is to say, it doesn't actually affect the original string. If you did want it to affect the original string, you'd have to reassign it. You'd have to do something like x is equal to the upper version case of x. So keep that in mind. I'm not going to run that right now because I want the original x string. And if you accidentally did a reassignment, you can always just say x is equal to hello world again. All right, so we have the upper method. Something that's really common for beginners as a mistake to make is that they accidentally just do upper and they forget those open and close parentheses. And if you run this, it'll just say, hey, this is a function string.upper. And basically what Python is saying is, oh, you haven't actually executed this method or function yet. Instead, you just asked me what it was. So when you call it without open and close parentheses and you get something that looks like this back, it means that you haven't actually executed that method or function to occur. Instead, you just kind of asked Python, hey, what is this? So because there's an upper method, there's also a lower method, which is going to lowercase every letter. Notice here now H and W are lowercased. Then there's also the split method, and the split method allows you to quickly create a list off of a string. So here we can say we have hello and world. Now we haven't really discussed lists yet, so they are coming up. So all I want you to think about right now is that if I use .split, it will split a string based on the white space or based on the letter you pass in. So let me show you what I mean by that. So I will say x is equal to, hi, this is a string. Run that. And then if I say x.split, I get back everything split by the white space. So I get, hi, this is a string nicely organized in a list. However, I could pass in any sequence of characters that I want to split on. So by default, split will split on the white space, but I could actually split it on any letter I want. So now it's going to split on the i's. So if I run this, we should get an interesting result. And here it's essentially removed all the i's because it's splitting on them. And now the white space is included. So I get h, and because there's an I there, it removes it and then gets everything until the next I, so space th. And then there's an I there, removes it, gets everything until the next I, which is an S space. So notice that's here, and then so on. Again, another I, and a big portion of string, get an I, and then an NG. So that's how you can use split to quickly create a list out of a string. And we're going to be covering lists in a lot more detail later on. Okay, coming up next, what we're going to talk about is string formatting for printing. There's a lot of useful methods you can use to quickly print out other objects along with your strings. So far, we've only learned how to use print as a basic function where we say print hello, but there's a lot more power to the print function that we haven't actually seen yet, as well as the .format method. So let's go ahead and cover that in the next lecture. We'll see you there. Welcome back, everyone. Let's now discuss string formatting for printing. Often, you're going to want to be able to inject a variable into your string for printing. So we already learned about concatenation. For example, you may have a variable called myname equal to Jose, and you want to print the phrase hello Jose. So what you may end up doing is say print, and then inside of that print function you say hello and concatenate it with the myname variable. Now there's actually multiple ways to format strings for printing variables in them, so you don't have to constantly be using this concatenation or plus sign. And this, in general, is known as string interpolation, which is basically just a really fancy way of saying stick a variable into a string. So we're going to explore two methods for doing this. One is the .format method, and the other one is the fstrings method, which stands for formatted string literals. And this is a newer method for some newer versions of Python 3. I personally prefer the .format method, but let's go ahead and show you both of them, and you can decide which is more your style. Let's get started. Okay, let's begin by discussing the .format method. And the basic syntax for this is you're going to have your string defined, and then inside of your string, you're going to have special curly braces as placeholders for the variables you're going to insert. And then right after the string, you call .format, and then inside of this, you're going to call the strings or variables that you want to insert into your string. Let's walk through lots of examples here. We're going to start with the most basic example, which is just saying this is a string, going to set open and close curly braces there, and right after the string, we're going to call .format. So notice how the dot is touching the string there, and then whatever string you want to insert. So to make it really obvious, I'm going to go put in all caps inserted. Run this, and now I see this is a string inserted. So what the .format method has done is it's grabbed this string and inserted it where it saw those curly braces. So there's several advantages here, and we're going to go through all of them. One advantage is that strings can actually be inserted by index position. Let's imagine that we want to insert many things. We're going to say the curly braces, curly braces, curly braces, then say .format, and say the fox, brown, quick. Now what happens is basically .format is going to insert these strings in the same order you supplied them and into these curly braces. So right now we have the fox, brown, quick. What would be nice is if we actually have this make grammatical sense, which is going to be the quick brown fox. What we can do is based off the index position inside of this format call, I can supply those numbers in the order I want. So the very first word I want is actually quick. So this is at index position 2 because it's 0, 1, 2. So I'm going to say, okay, 2 goes first here. And then the next word I want is going to be brown. So that's at position 1, so 0, 1. And then the first word, fox, at index 0 here, is going to be the last one I want. And then when I run this, I get back the quick brown fox. What's also really nice is I can actually repeat these. So if I wanted to say the fox, 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 I could just say the 0, 0, 0 here, run this, and now I have the fox, fox, fox. So I can play around with this in case I ever want to work based off of index position. Now what's also nice is that not only can I call things off the index position, I can also assign them keywords and then just call the keywords. Because here, as I'm working with this, there's no real indication that 0 is fox. Instead, I just have to look over here and say, okay, what was the first word? What I can do is assign them keywords. So let's do this. We're going to say the curly braces, curly braces, curly braces, say dot format, and then inside of the dot format call, I'm going to say f is equal to the string fox. So you can kind of think of this as a variable assignment. And then we'll say b is equal to brown. And we'll say q is equal to quick. And then I can use these variable names here, f, b, and q, to insert them. So it's basically using these keywords as variable names here and inserting them that way. So inside of this, I'm going to say the q, b, f. And then when I run this, I get back the quick brown fox. And this is even nicer than previously because it's a little more readable to someone using it like, oh, okay, Q stands for quick, instead of having to look back and ask yourself, okay, well, what was index position 2? And then coming over here to format. So this is able to use these keywords, and I actually really prefer it this way myself. And what's also really nice about this, if again, for some reason you wanted to say the fox, 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 you could just type in F here into each of these braces, and you would get back the fox, fox, fox. So again, using keywords, you can use repetition easily. Okay, to finish off our discussion of the dot format method, I want to briefly talk about float formatting with the dot format method. And basically, this allows you to adjust the width and precision of your floating point number. Let's start with an example. We're going to say result is equal to 100 divided by 777. So as you may expect, this result is a number with a ton of decimal points after it. What we can do is we can actually, when we're printing this out, change the level of precision we want and even change the width of the number itself. So we're going to start off by saying print, the result was, and then open and close curly braces, say dot format, and then here we'll say result, run this, and we see the result was, and it's basically this kind of large precision number. What I can also do is say r is equal to result, and then pass in an r inside these curly braces, and I get back the same result. So the way the formatting works for float formatting, as far as the dot format method, is you pass in the value that you're referring to. So in that case, it's r here, that's the actual value name. Then you write a colon, and then you write in the width value you want, dot, and then the precision value you want, and then an f. And often what you're really going to care about is the actual precision. The width just allows you to kind of add in some white space if you have a really large width value. So let's do the following. We're going to say value, so that's r colon. We're going to set our width just equal to 1, then a dot, and then the level of precision we want. So this is mainly what you're going to be playing around with, this precision value. Let's imagine I only want 3 places past the decimal point. So I want 1, 2, and then 9, because 8's going to be rounded up to 9 due to the 7 right next to it. Then I would say 1.3 f. I run this, and I get back 0.129. Now, if I play around with this width value and make it really large, what ends up happening is you end up adding white space. And the reason for that is because the width basically describes how long or how wide you want this entire string number to be. That's not terribly useful because you end up writing a ton of white space, but there may be certain situations where you kind of want to edit that. So it is available to here, but often what you're going to be playing around with is really the precision here. So we can make this 5, and here we can see now we're taking up less of the total width because with white space, because we have more numbers past the decimal point. And you can just generally keep it as 1, but let's go ahead and show you another example. We're going to say result is equal to, let's say 104.12345. Run that, and we can see here that even with 1 on the other side of the decimal point, that's essentially just the same thing, and we can edit around and play with this floating point value. Okay, so that's float formatting with the dot format method. Again, it's the value, your width, and really your precision followed by f. And you can check out the notebook for a lot more examples on this. Finally, what we're going to talk about is f-strings, and these are formatted string literals. These were introduced in Python 3.6, so they're still very new. And they offer several benefits over this older .format method. I generally prefer the .format method, but a lot of people prefer this string literal method, especially if they're coming in from other languages. And what it allows you to do is basically skip this step of using .format and instead write result, or whatever variable name you want, directly inside the string. So the way we do that is the following method. I'm going to create a couple new cells here. I'm going to say name is equal to Jose, run that, and then typically what I would have to do is say, hello, his name is, and then I would say .format name. I run this and it says, hello, his name is Jose. What you can do is replace the .format call by just typing an F in front of the string here, and then you can pass in name directly into the string itself. And if you run this, you get back the same result. So this is called f-strings, or formatted string literals, and this is new with Python 3.6. And a lot of people have been requesting this feature for a long time because it's quite common in other languages. Again, because I'm a little more old school, I got really used to this format method, which is why I like it so much. But if you're coming in from other languages, I would definitely suggest you check out the f-strings. A lot of people think it's a huge improvement over the previous method, and you can see why. It's actually really convenient to just be able to write that variable name directly inside these curly braces. And this works with multiple variables. So let's say name is Sam, age is 3. What we can do is say print f to let Python know it's a f string. We'll say in curly braces, name is, in curly braces, age, years old. And if we run this, we see Sam is 3 years old. So this is a really nice way to very quickly do string interpolation, which is just injecting these variables into the string itself. Okay, those are the very basics of string formatting. We have a lot more examples in the notebook in case you're interested. And we also have examples of some older string formatting methods that technically still work in Python 3, but I would really recommend that you either use the .format method, or if you like this new fstring method, use that as well. I'm going to briefly just show you what the notebook looks like for this lecture. So you can see here we have a ton of string formatting examples for you, formatting with placeholders, which is something we didn't talk about this video lecture because it's quite an older method and I wouldn't really suggest you use it. But you can also see how we can use precision and padding for floating point numbers. We also have a lot more examples with the .format method, inserting objects by index position, reusing them. We also have alignments, precision. So all this stuff, a lot of this stuff we're not really going to use throughout the course, but it is available to you in the notebook in case you want to dive really deep into this topic. So we have lots of examples for you there. Okay. Again, all you really need to know about string formatting for this course is that you can use f-string literals to inject and interpolate strings this way, or you can use the .format method to inject variables that way. Okay, hope that was useful to you. We'll see you in the next lecture. Welcome back, everyone. Now let's begin discussing lists in Python. Lists are ordered sequences that can hold a variety of object types, and they use square brackets and commas to separate the objects in the list. For example, here we can see a list of numbers 1, 2, 3, 4, 5. And lists, just like strings, support indexing and slicing. And lists can also be nested and have a variety of useful methods that can be called off of them. Let's explore all these concepts in a Jupyter Notebook. Let's begin by defining a variable called myList, and we'll set it equal to the numbers 1, 2, 3. So here we can see that a list is defined by these square brackets, and then we have every object type separated by a comma. We just created a list of integers, but we could have also created a list of mixed object types. So the first one could have been a string, the second one could have been a number or a floating point, and this list has no problem. So we can see Python lists are very flexible in the data types they can hold. And if we ever want to check the length of a list, just like we could check the length of a string, we just use the len function that's built into Python and then pass in myList, and it returns back how many elements or items are in that list. So here we have 3 items, string 123.2. Now, just like a string, because a list is an ordered sequence of elements, we can use indexing and slicing. And this works just like a string. So let's show you what I mean by that. I'll say myList is equal to, let's say 1, 2, 3, run that. And then if I wanted to grab the element at index 0, so that's the very first element, I would just say mylist 0, run that, and I get back 1. And if I wanted to grab everything starting at index 1 all the way to the end, well, it's just like string indexing and string slicing. I would say, hey, start at index 1, colon, go all the way to the end, and then we have 2 and 3. So this slicing and indexing works just like a string. And you can also concatenate lists together. So let's see this right here. I have my list right now, which is 1, 2, 3. I'm going to create another list, which is equal to, let's say 4, 5. And I can say my list plus another list, and it will concatenate to a new list, 1, 2, 3, 4, 5. Notice here, I'm not actually saving this result. So if I were to call back my list or another list, I can use tab autocomplete here. I still have those two separate lists. If I actually want to save this, I need to assign it to something. So we can say new list is equal to my list plus another list. And then if I check out new list, now it's 1, 2, 3, 4, 5. Okay, so those are the basics of lists. So notice right here we have the indexing, slicing, and concatenation. Should feel pretty similar to a string, except what's different than a string here is that we can actually mutate or change around the list. Remember back when we were trying to change letters around in a string, it wouldn't let us. A list has no problem in that manner. So if I check out my new list, it's 1, 2, 3, 4, 5. Let's go ahead and change one of these elements. Let's change 1 to be in all caps. What I could do is say new list at position 0 is now equal to 1 in all caps. Now let's make it really obvious that we're changing it. So I'm going to say 1 all caps. And now if I take a look at my new list, I have 1 all caps, 2, 3, 4, 5. So that's a way you can actually mutate or change the elements that are already in a list. And that's something that differentiates it from a string, besides the fact that it's also holding different element types in braces and commas. So again, strings, you can change them and affect elements inside of them. Another common operation that you may want to perform is to add an element to the very end of a list. And the way we can do that is we say new list dot and hit tab here, and you should see all the various methods that are available to you in a list. The one we're going to show here is the append method. An append allows you to append a new item to the end of a list. So we'll say append 6. And after running this, what we're going to see is that if I check out my new list, I have 1 all caps, 2, 3, 4, 5, and I have 6 now. So notice how append does actually affect the list, and we call this affecting it in place because it permanently changes that new list to have an element at the end of this. So this is known as append, and again, it allows you to place any item at the end of a list. Let's try it one more time. We'll say new list, append, let's say 7, run that, and let's check our new list, and I can see 1 all caps, 2, 3, 4, 5, 6, and then 7. Just because I'm very zoomed in here, it's kind of cutting it off. But if you were to zoom out, you'd start seeing it in a more normal fashion. All right, so we know how to add things onto a list. Let's talk about removing items from a list. To do that, we can use the pop method. So pop is actually going to pop off an item from the end of a list. Let's show you what we mean by that. We're going to say new list dot pop, open and close parentheses. Remember, for a lot of these method calls, if you don't have parentheses there and you just run them, it's going to report back, hey, that's the pop function inside of this new list object. If you actually want to call it, then you need open and close parentheses. And later on, we'll discuss the differences between methods and functions. You've probably heard me use those terms a little bit interchangeably right now. We'll go into a lot more detail about them later on. But right now, we saw that we said new list.pop, and it's popped off the 7, and it's actually returned it as well. And if we take a look at what new list is now, it no longer has the string 7 in it. Now it just goes up to the string 6. So let's actually save the result of a pop. So we can say popped item is equal to new list. And I'm going to say dot pop. And when I run this, what's going to happen is this popped item is now the item that was at the end of that list. So I can copy and paste this popped item, and now I have 6 saved as the pop item, and it's no longer as part of my list. Now, a common question that arises here is, hey, I don't want to remove something from the end of the list. I want to remove it at a specific index. For instance, I want to remove the one all caps at index 0. Well, it's actually no problem. You can pass in an index position into the pop. We can say new list dot pop and then just pass in the index position of what you want to remove. We can see here that one all caps is at index position 0. So let's pass in 0 there, run it, and we can see that we've popped off one all caps. And if we see new list now, we have 2, 3, 4, 5. So again, pop basically removes items from the list at whatever index location you provide. By default, the index location is -1, the very end of a list. So reverse indexing also works with a list, just like it worked with a string. A few more methods that I want to discuss besides pop and append, which are going to be really common methods you're using, is sort and reverse. So to do this, I'm going to create a new list. Let's zoom in here. Or I'll redefine new list. And I'm going to redefine new list to be a couple of letters here, but we're going to have them sorted out of alphabetical order. There we go. And we'll also make a numbers list. So we'll say numList is equal to, and let's make this just a bunch of numbers out of order as well. Okay, so we have 2 lists. If we ever want to sort these lists, what we can do is call the sort method off of them. We can say new list, sort, and you can use tab autocomplete to do this, open and close parentheses, and this is actually kind of a special in-place method because it doesn't actually return anything. Instead, what it's doing is it's going to sort new list in place, meaning that it doesn't return anything. Instead, when you call back new list again, it's now sorted in alphabetical order, A, B, C, E, X. And that's an important distinction to make because a lot of times beginners will do something like this. They'll say, oh, my sorted list is equal to new list.sort. But what's going to happen here is because new list.sort occurs in place, it doesn't actually return anything for you to assign. So when you call my sorted list, you get back nothing or none. And you can actually check the type of this, and it's going to say that it's a none type. And what none type is the type for a none object. So there's actually a special object in Python called none. Notice the capital N there. And this is just something you can use to indicate no value. And a lot of times people hold it as a placeholder, but really what it is, it's the return value of a function or a method that doesn't actually return anything. So it's a common default return value for functions that maybe search for something and may or may not find it, for example. So that's an important distinction to note here, that when you're using this .sort method, it's actually occurring in place, so you're not going to be able to reassign the result to something else. Instead, if you did want to do that, what you'd have to do is say new list .sort and then say my sorted list is equal to new list. And then when you run that, you can have my sorted list. I'm using tab autocomplete there, and you'd get back your sorted list. So let's try that num list again. So right now num list is unsorted. If I call the sort method off of it, and I check num list again, now it's sorted. All right, let's also discuss the reverse method off a list. As you may have expected, it's going to reverse everything in your list. So it's just reverse, open close parentheses, run that, and it's also in place, meaning it doesn't return anything. And when you call your reverse version of your list, now you have 8, 4, 3, 2, 1. All right, that's really the basics of lists. And the most important methods to understand are the append method and the pop method, as well as the sort and reverse method. And just like strings, we're able to perform indexing and slicing. So if we come back up here, we're able to say indexing as well as slice notation like up here. So that works just like you would expect it to work as it did in strings. The only thing to note here is, unlike strings, we're able to do reassignments like we did up here with a list. Okay, that's the basics of a list. Coming up next, we're going to discuss dictionaries. I'll see you there. Welcome back, everybody. Now it's time to talk about dictionaries. Dictionaries are unordered mappings for storing objects. Previously, we saw how to store objects in an ordered sequence using a list. But now, dictionaries will allow us to store objects using what's known as a key-value pairing instead. And this key-value pair allows users to quickly grab objects without needing to know an exact index location. Instead, you just call the key and it returns the value associated with that key. And the dictionary syntax uses curly braces and colons to signify the relationships between a key and their associated values. So here we can see the curly braces, and then we have the string key, so key 1, then colon, and then whatever value is associated with that. In this case, we just have a string called value 1, and then we have a comma for the next key value pair. Now the question always arises, when do we choose a list, and when do we choose a dictionary? Well, dictionaries have objects retrieved by a key name, and dictionaries are unordered and cannot be sorted. So a good time to use a dictionary would be when you want to quickly retrieve a value without needing to know its exact index location. Now that's a really nice feature of a dictionary, the fact that you don't need to know where something is in the actual dictionary to call it, you just need to know the key value pair. However, that comes with the con of not being able to sort a dictionary. Because a dictionary has a key value mapping, it means that it's going to insert new key value pairs wherever it deems most efficiently. Lists, on the other hand, can retrieve objects based off locations. So that allows the actual list to be indexed, sliced, and then sorted. So you kind of lose that functionality when using a dictionary, so you're basically trading off ease of calling and grabbing something from a dictionary very quickly with a key value pair, and you're losing the ability to sort things or have an index location off of them. Okay, let's explore these concepts a little closer by jumping to a Jupyter Notebook. Let's begin by showing you how you can construct a dictionary. We'll start by saying, or create an object, my dictionary, and then we'll have curly braces, and we'll define a key. So keys should be string, and you can call them whatever we want. So we have key 1, and then we have some associated value with that key. For now, we'll stick with basic strings. Then we have a comma, and you can insert a new key value pair. So a colon, and then another value for that. Okay, so we have our dictionary here. And then if we call it back, we'll end up getting the entire dictionary. But really what we want to do is grab values from this dictionary. So instead of using index locations, we still use the same square brackets, but now to get a value back, we just pass in the key that's associated with that value. So we can say in my dictionary, pass in key 1, and we get back that value itself. So a good example of a use case for a dictionary may be something like prices in a store. So we can say I have a dictionary called prices, and we can even call it price lookup. So we have this prices lookup dictionary, and we can have different items in the dictionary, such as apple, and then their associated price. So we'll say apples are, I don't know, $2.99, maybe per pound, whatever. These are made up prices. We can have oranges. Those can be $1.99, and then we can have, let's say chocolate. Well, let's say milk, because it's a little shorter type. We'll say milk, and that's going to have a price of $5.80. And there we go. So then, with my dictionary, and remember this dictionary could be huge, prices lookup, I would just want to know, hey, what's the price of an apple? I'd pass an apple, run it, and it returns back the actual price. And now, without needing to know any sort of index location, I can easily get the prices of any of these objects using the key value pairs. So that's a really good example of why you would need a dictionary instead of something like a list, because here I have two values that I want to associate with each other and quickly look up the value of one given its key. Now it's important to note that dictionaries are actually super flexible in the data types they can hold. I just showed you how they can hold integers or floating point numbers as well as strings, but they can actually hold lists or even other dictionaries. So I'll just show you this as an example. We'll say D is equal to, we could have K1 be equal to a key, and it could have a number associated with 1, 2, 3. Or the other thing I could do is say K2, and I can actually have this have a list associated with it. So I can say 0, 1, 2, and then I can even do another dictionary inside of this dictionary. This is not that common, but it is supported. So we can say inside key, and then have some other number here, 100. So the dictionary itself has no problem dealing with all of this. And if we ever want to grab elements from this, let's imagine I wanted to grab this list, 0, 1, 2. Then I just call D, pass in its key, K2 in this case, whoops, it should be a string. Run this and I get back the list. And then if I wanted to grab this number 100, what I could do is say D, find the associated key for that, K3. And when I run that back, I get back this dictionary. So off of this, I can make another key call. So then I could just say inside key, copy that, run that, and then I get back 100. So notice what's happening here. I'm basically stacking either index calls or key calls to get back the values I want. So let's imagine that I wanted to grab the number 2 here. What I would need to do is say D, K2, which returns back a list, and then I want the item at index 2. So then I could just say 2, and then I grab back 2. And this whole thing can be a little confusing at first, so let me walk through one more example just to make sure this is clear. I will say my dictionary has a key 1, and associated with this key is a list of lowercase letters, A, B, C. I run that, I check my dictionary, key 1, A, B, C, and let's go ahead and try to grab the letter C and make it uppercase, because it's a string. What I could do is, through various steps, do the following. I could say my list is equal to D at key 1, and then if I check my list, I have that, so then I could say letter is equal to my list at index location 2, and then if I check out my letter, I then just say letter, uppercase, and then I have capital C. So notice all the steps here that I did. I first grabbed the key, then I made that into a list, then I did the indexing off that list to grab the letter, and then I said uppercase off that letter. But I can actually do this all in one step because of how flexible Python is. I could say, okay, grab that key, which returns back the list. So then off of this, instead of reassigning it, I can just keep calling what I want. So then I want to index by 2. There I have the letter C. And now that this is a string, I can call .upper, and there I have uppercase C. So you could do it this way as well, instead of having to do each of these steps. Now you're not going to be doing something like this so often, but you do sometimes leverage the power of dictionaries to be able to hold lists inside of them. Okay, so I just want you to be aware of that you can kind of stack calls like that on a singular object. If we ever want to add new key value pairs to a dictionary, it's pretty straightforward. So let's make a new dictionary here. We're going to say K1 is 100, and we'll say K2 is 200. So here I have my dictionary, K1 and K2. Let's imagine that I wanted to add K3 is 300. All I need to do in that case is say D, assign a new key, so K3, and set that equal to 300. And then when I take a look at the dictionary, I now have K3 300. All right, so we just saw how we could add a new key value pair to the dictionary. We can also use the same method to easily overwrite an existing key value pair. We can say D of K1 and set that equal to some new value. So to make it really obvious, we'll just have a new string there, new value, and then if we call D, we see K1 now has that new value associated with it. Finally, I want to discuss just a few useful dictionary methods, and those are methods to grab all the keys, values, or items off a dictionary. So we have our dictionary right now, K1, K2, K3, new value 200, 300. I'm going to reassign it to be the old one. So let me copy this right here and say D is equal to that version of the dictionary. If I want to see all the keys of a dictionary, I can say D.keys, and that's going to return back all the actual keys. If I want the opposite and I want all the values, all I need to do is say D.values, and that returns back the values. And then if I want the actual pairings together, I can say D.items, open and close parentheses, run those together, and it returns back the pairing. So K1 goes with 100, K2 goes with 200, K3 goes with 300. And these, you'll notice, are actually in parentheses, and that means this is actually a tuple, which we're going to learn about very soon. Okay, that's really the basics of dictionaries. Let's do a very quick overview of what we just learned. Dictionaries, their main syntax is defined by curly braces. You have a string key, colon, and then a value. And Python's really flexible as far as what this value can be. It can be another string, another list, another dictionary, floating point numbers, integers, etc. And then you can have another key value pair, and you just separate these by commas. The keys themselves should always be strings. And then we can easily look things up by just a key lookup. Again, it uses that same bracket notation we saw earlier with indexing, except now instead of passing in an index position, you pass in the key itself. We also saw how we can call nested objects inside a dictionary by just basically piling on these key and method calls. Then after that, we saw how we could call the keys, the values, and the items off a dictionary. All right, that's the basics of dictionaries. We'll dive into more detailed aspects of dictionaries later on. We'll see you at the next lecture. Hi everyone, and welcome to this lecture on tuples, or tuples as some people like to call them. And in Python, tuples are very similar to lists. However, they have one key difference, and that is they have immutability. So they're immutable, meaning they cannot be changed. And that comes from the term mutation, so they cannot be mutated or changed. And that basically means once an element is assigned to an index position inside a tuple, you can't grab that element and then reassign it to something else like you could with a list. And the way you construct tuples is very similar to a list, except instead of using square braces, you use parentheses. Let's explore tuples a little more in a Jupyter Notebook. All right, so let's get started. Hopefully you'll have quite an intuition as far as how to use tuples based on what you've learned about lists. We're going to create a tuple called t. We'll say t is equal to, and then in parentheses we'll write 1, 2, 3. And I'm also going to create my list, which is going to be very similar. We'll say 1, 2, 3, but notice it's square braces, so it's a list. And you can always confirm this using the built-in type function. So if I say type t, it returns back that it's a tuple. And if I ask type my list, it returns back that it's a list. Okay, so you can check the length of a tuple just like you could with a list. So length of t is 3 because there's 3 elements in that list, 1, 2, and 3. And just like a list, it's also fine to mix object types. So we can have a string inside of a tuple along with a number. That has no problems there. And also, just like a list, you can use slicing and indexing. So let's say I wanted to grab that string 1. I could just say, give me what's at index 0, 1 there. I can then also do -1, and I have 2 as a return because it's the last item in that tuple. So far, very similar to a list. There's also 2 basic built-in methods for tuples, and that is the index method and the count method. Let me show you an example of that. We're going to say t is a tuple with a, comma, b. And let's imagine we wanted to count how many times the letter A shows up in this tuple. I can say t, and then if you hit tab here, you should see the 2 options you have, either count or index. So right away, you'll notice that there's way less methods available for tuples than there are for lists. So we're going to say t.count, and then we'll pass in a, and it returns back how many times a occurs in that tuple. And then what you can also do is say t.index of a, and this returns back the very first time this appears in your tuple. So notice that if it appears more than once, it'll only return back the index location that it appears at first. And if we do the same thing for b, the very first time a b occurs is at index 2. So if we take a look at t, it's right here, AAB. Later on, we'll learn how to use control flow logic like for loops to grab all the index locations of repeated elements. And finally, let's get to really what makes a tuple different, and that's the immutability. And I really can't stress enough that this is what makes a tuple different than a list. So let's check out our tuple right now, and let's also check out that list we created, my list. Let's reassign the first element of my list to be the string new. So right now, my list has no problems with that. It says, okay, I'll reassign the first element to be new. If I try to do the same thing with the tuple, and I say new here, it's going to say type error, tuple object does not support item assignment. And that's basically what makes a tuple different than a list. Now I'm sure you're wondering, well, why would I even bother using tuples when they have fewer available methods and they don't have the flexibility of a list? And to be honest, as you're beginning to program, you're not going to be using tuples that often. It's only as you become more comfortable with Python and become a more advanced programmer that you'll begin to see the benefit of tuples. And what you're going to be using tuples for mainly is when you're passing around objects in your program and you need to make sure that they don't accidentally get changed. and that's when the tuple really becomes a great solution. So it provides a very convenient source of what's known as data integrity. The fact that we can't do reassignments like this by accident, we'll get an error instead, is going to be really useful when you want to make sure that elements don't get flipped or reassigned later on in larger pieces of code. So kind of keep this in your toolkit, and later on I'm sure we'll be pulling out the tuple again so we can use it and really let it shine. For now, just remember that it has immutability and it looks really similar to a list, except we use parentheses instead of square brackets. Okay, that's it for tuples for now. Up next, we're going to show you how to do basic file input and output. We'll see you there. Welcome back, everyone. In this lecture, we're going to very quickly cover what sets are. And sets are unordered collections of unique elements. And this basically means that there can only be one representative of the same object. So you can't have the number 2 in there more than one time, or the letter A in there more than one time. Let's see some examples of how to work with sets in the Jupyter Notebook. To begin, let's create a set, and we can do that by saying my set, or whatever variable name you want, is equal to set, and then open and close parentheses. So right now we have my set, and it's just an empty set, so it returns back set. If we actually want to add an object to the set, I can say my set, and then call the add method, and we can add one object to this. So let's add the number 1. And now if I take a look at my set, I see it has the number 1 there. Now notice it looks like it's a dictionary because of these curly braces, but it's not because it doesn't have key value pairs. It's just unordered collections of any items you want. So let's add in another object here. We'll say my set, add in the number 2, and then if I call my set again, whoops, if I call my set, I get 1 and 2 there. Now let's try adding 2 a second time and see what happens. If I call my set, it still just shows 1 and 2. It doesn't show 1, 2, 2. And this is basically what a set is. It has to be unique values in there. If you try to add a value that's already in the set, it won't repeat it. It'll just say, hey, we already have that value in there. I only accept unique values. So when you're working with sets, it may not be super useful to add them in this manner. Instead, what it's really useful for is maybe casting a list to a set that way you only get the unique values. So for instance, we'll say my list is equal to, and I'm going to place a bunch of repeated values in here. A bunch of 1s, a bunch of 2s, and a bunch of 3s. I'm going to run this, and then I'm going to cast this as a set, and now I get back only a set of the unique values. Keep in mind, sets don't technically have an order to them. Since we're dealing with very small sets here of just a few items, it looks like they have an order, but in reality, sets don't have any particular order to go in. For now, that's all you need to know about sets. We won't really touch upon this object or data type again until much later in the course. Since we're just beginning, it won't be very useful to us now, but later on we'll be able to see different use cases for it. Again, remember just that sets are unordered collections of unique elements. Thanks, and we'll see you at the next lecture where we discuss Booleans. Hey there, welcome back. In this lecture, we're going to briefly discuss Booleans. Booleans, in case you're unfamiliar with this term, is basically a term to use for operators that convey either true or false statements. And these are really important later on when we deal with control flow and logic, because lots of times we want to check if a certain condition has happened. In other words, if a certain condition is true in order to execute some code. For example, you may want to check, hey, is my pool empty? If that is true, then go ahead and turn on the water to fill up the pool, or other things of that nature. So that's why Booleans are really important. And a lot of times we won't be dealing with Booleans directly in the terms true and false, but we'll actually have comparison operators and logical operators that return a Boolean value. So let's very quickly show you what these actually look like, and then we'll explore them later on in a lot more detail when they become more useful to us. Let's hop over to a Jupyter Notebook. Okay, so Booleans, there's true and false, and in Python you need to make sure that you have capitalized T in order for it to be true. Otherwise, if you have lowercase t, it's just going to complain, hey, you didn't define this term true because it thinks you're calling a variable. Instead, make sure that you have capitalized T, and it's the same for false. You're going to need to capitalize F for false. So here we have true and false, the main Booleans, and we can check their type by saying type Let's make sure I capitalize that T, type false, and it says BOOL for Booleans. And Booleans is what we're going to be dealing with when we're dealing with logical code. And a lot of times what we're going to be doing is working with comparison operators to create Booleans. And we're going to go over all the comparison operators later on in this course, but to show you a very simple example, there's comparison operators that check if something is greater than something else. So we can say, hey, is 1 greater than 2? So there's just a simple mathematical expression there. And it returns back a Boolean false. 1 is not greater than 2. And then you can do other things like check for equality with 2 equal signs instead of just a single equal sign. So is 1 equal to 1? Run that and it returns true. So these are called comparison operators, and we'll be showing you all of them later on in this course, but we first have to tell you what they actually are returning, which are Booleans. All right, so those are Booleans, just simply true and false, and the type is BOOL. They'll be critical later on in this course. And finally, I want to mention that we can use the none keyword as a placeholder for an object that we don't want to assign yet. So maybe later on I want to assign B to something in my code, but for right now I just need to have a placeholder for it so I don't get this error of, hey, B is not defined. What I can do is say B is equal to none, notice the capital N there, and it's a none data type. And we've actually seen that before when we were dealing with in-place methods off a list. Remember that when we sorted a list in place, it returned back none. So when I type B here, I don't see anything out. But then what's nice is I also don't see that error of it not being defined. Okay, that's really the basics of Booleans. We're going to work on this a lot more later on in the course. I'll see you at the next lecture. Welcome everyone to this lecture on files. And before we finish off this section of the course, we already learned about all the basic data types. I now want to quickly go over how to perform simple input and output with a basic text file. And the methods we show here will also expand further to working with other file types, whether it be an audio file, text file, emails, Excel documents. A lot of what we cover here is going to be really relatable to those more advanced functionalities. Now keep in mind, for some of those other topics, you may need to install certain libraries, which we're going to discuss later on in this course. For right now, we're going to deal with just basic.txt files. So we're going to create one using the Jupyter Notebook, and we'll also discuss file paths on your computer. Let's get started. To begin, what we need to do is create a text file to work with. Now, if you downloaded those notes, there's actually already a test.txt file. So in your folder somewhere, there should be a test.txt file in the same folder as these notes are in. So keep that in mind, but I'm going to show you how you can use Jupyter's magic functionality, or so it's called, in order to quickly write a text file. So this only works in Jupyter Notebook. So write %, write file, space, my file.txt, or whatever you want to call it. So this has to be on the first line of the cell. And then here you can just write plain text of whatever you want is in the cell. So I can say, hello, this is a text file. This is the second line. This is the third line. Let me make sure I spell that right. So again, this only works in a Jupyter Notebook. If you don't have Jupyter Notebooks, maybe you're working in Sublime Text Editor, go ahead and just write this into a file and save it as a .txt file in the same location as wherever your scripts are running. So we're going to run that, and you should see successfully wrote my file.txt file. And now what we can do is actually open up and play around with these files. Now it's a very common mistake to accidentally either write the wrong name of the file or save the file in the wrong directory. So let me show you what that typically looks like. We'll say my file is equal to, and we use the open function. And in this case, I know my file.txt is there because I can just write my file.txt, and we need to write this as a string. So write that, and then we'll get no error because it happens to be there. If I ask for a file that is not there, we'll say my file is equal to open, and we'll say, whoops, wrong txt. So I definitely know there's no file there. If I run this, we'll get a file not found error. So this is a really common error. It's called error number 2. No such file or directory. Whoops, wrong.txt. So there's really only two possible ways to get this error. One way is that we accidentally passed in the wrong file name. So in this case, I wrote whoops, wrong txt file. So that's the wrong file name. The file name should have been my file.txt. Now, the other possibility is that I actually didn't provide the correct file path. And we'll discuss that more later on in this same lecture. But maybe you have whoopswrong.txt on your computer, but it just doesn't happen to be saved in the same location as your Jupyter Notebook. To know where your Jupyter Notebook currently is, you can type pwd into a cell, run that, and that will print your working directory. So this directory is where this notebook is currently located, and that's the same location that any .text files you want to work with should be saved. Later on, we'll show you how to call a text file from any location on your computer, but for right now, make sure that the text file you're working with is saved to the same location that is output when you type pwd. All right, continuing on, we know that myfile.txt is in the same location because we use this special command to write it there. And if you don't want to use a special command, you have the test.txt file from the zip file of notes. So let's continue on here. We'll say myfile is equal to open, and we're going to open that text file we just made, which was called myfile.txt. myfile.txt, run that. And now there's several methods I can call off of this. One method I can call is the read method. And what this does is it returns just a giant string of everything that's in this text file. Sometimes that's good, sometimes you don't want that, but it is a method that's available to you. You'll notice here that we have this \n, and what this does is it indicates a new line. Because you asked for everything as a single string, the string somehow needs to represent where the new lines were in your text file. Because remember, we wrote, hello, this is a text file. Here on a second line, we wrote second line, and on a third line, we wrote third line. So in order to represent that, we have these escape sequences that we discussed earlier in the string lectures, and \n represents new line. Now, if I try to read this file again, you'll notice something funny happens. You get back an empty string. So a lot of times beginners are scratching their head thinking, well, what the heck happened? I just read it, and now when I try to read it again, it's no longer there. The reason this is happening is because you can imagine that there's a cursor at the beginning of the file, and when you read it, the cursor goes all the way to the end of the file. And you need to reset the cursor or seek it back to 0 in order to read it again. So to do that, you can say myfile seek 0. That resets the cursor. You should see some 0 output there. And now if you call read again, you'll be able to see this. Keep in mind, if you ever want to read again more times, you'll have to reset that. You'll have to say myfile seek 0. And then you say myfile read, and let's save this as contents. And now if I check my contents, that's just one giant string. So that's the read method, and it allows you to grab everything as one giant string. Sometimes that's not really useful because you'd actually want to have a list where each single element in the list is one line in a string form of the actual text file. And to do that, it's actually quite simple. You can use the read lines method. So we're going to seek back to 0 and then say myfile read lines. And note what we get back here. Now we have each line as a separate object or element in this list. And a lot of times this is more convenient to work with because now I can loop through this list, which we'll learn about later on, or I can index off of this list for the lines themselves. All right, so those are the basic methods of reading a basic text file, which is .read to grab everything as a string, or read lines to grab a list where each element represents a line. Keep in mind, you still have that \n there at the end of that. Let's move on to discussing file locations. Now previously, we just showed you how to open a text file that happens to be in the same location as your Python script or Python notebook. But what if you want to open a text file that's saved in another location on your computer? It'd be really annoying to have to constantly be moving around your Python scripts or your notebook location to be at the same location as that text file. So to open a text file that's at any location on your computer, all you need to do is provide the full file path. Keep in mind, however, the syntax for a file path is slightly different depending if you're on Windows or if you're on macOS or Linux. So for Windows, the typical file path is going to look something like this. You'll say C:, and then note that we have the double backslash, and this basically is an escape character so that Python doesn't confuse this first backslash as an escape character. because imagine if your username had a lowercase n, you don't want Python suddenly thinking you mean new line. So that's why we have double backslashes here. So this is for Windows, and it looks something like this. And you just pass in the whole file path as a string to your text file. If you're on macOS or Linux, it looks a little different. You have forward slashes here, and it goes users, your username, whatever folder, and then to the text file. If you ever want to check what this actually looks like, all you need to do is use that handy PWD into a cell again, and you'll notice that I already have kind of the format of what it should look like. I'm running this on a Windows computer right now, so it shows me what the format is, and then from there I can copy paste and then play around with this, add folder paths, etc., in order to grab the right text file. To finish off this discussion of files, I want to mention best practices for opening files. Right now, we open this file and we called it my file, but technically because it's open, we actually have to close it. We have to say myfile.close in order to not get any errors, because let's say you opened this file somewhere else on your computer and you were trying to delete it, you'd get an error saying, hey, Python is still using this file, and you'd have to actually manually close it once you were done working with it. To avoid any such errors, what you can do is use the special with statement. And it looks like this. You'll say, instead of saying something like this, let's first see the old way, which was my file open test.txt. So that was the old way of doing things. And I believe it was called myfile.txt. What we can do is say with open, and then we'll say as, and then whatever you want to call this. You can say my new file. So this is the variable name you choose. And then you have a colon there. And then notice what happens here. When I hit enter, I have an indentation. And basically what this means is that any code here that's within this block, this indented block of code, is going to use my new file as the variable of this text file. So then I can say contents is equal to my new file read. And when I run this, I no longer need to worry about closing the file. Let me quickly check that that was the right text file name. We'll come up here and confirm that, and we were right. Okay, so let's run this and see what happens. So I run that, and now I no longer worry about closing the file, and I can still grab the contents that were in this block of code. And we're going to get used to this idea of these indented block of codes a lot more in the next section of the course. Okay, let's finish off this discussion by talking about reading and writing to a file. Right now, you may have noticed that we've basically just been reading files, but we can also write to files and overwrite files. And that's a key difference that we need to appreciate. So we're going to say with open, and I'm going to say with open myfile.txt, comma, and what I'm going to do here is right with my cursor right next to open, I'm going to do shift tab. And what this does is it opens up information for functions that have already been defined. So later on, we're going to define our own functions, but you'll notice open is a built-in function. So you can see here some documentation, and this is why I love using the Jupyter Notebook for teaching Python, because just with the term shift tab right next to the function, you get all this really useful information. You can have plus here to see even more stuff. So you basically have the documentation right here in your notebook without needing to go online. All right, so notice here there's a mode, and it's set by default equal to R. So we're going to copy this and paste it right here. Say mode is equal to R, and then say as my file content is equal to my file read. So when I run this, there's no problem. I see the contents, and there it is. Now let's switch this to W, which stands for write. If I try running this cell again, it will say, hey, unsupported operation, not readable. And that's because depending on what mode you choose for opening your files, you may only choose to write to a file instead of being able to read to a file. And this is basically known as permissions. Sometimes you're going to want certain scripts to only have permissions to write to a file or only have permissions to read to a file. And sometimes you want them to have both. So what we can do here is the following options. We can use R for read, or W for write, and this will overwrite files. Or we can use A to append to files, and append is basically just adding more lines to the end of a text file. Okay, so let's take a little bit of time to discuss the reading, writing, and appending modes. So we just showed you that you can edit that mode. Let's discuss all of them very quickly one more time. If you set mode is equal to R, that's read only. If you set mode equal to W, that's write only. So this will overwrite files that already exist. Or if you try to open a file that doesn't exist already and you open it with mode W, it'll actually create a new file, and we'll see that in just a second. And then mode A is to append only, and this adds on to files. R plus is for reading and writing, and then W plus is opening a file for both writing and reading, and that again will overwrite the existing file if the file exists. If the file does not exist, it creates a new file for reading and writing. So to play around with these, let's create a new file, and I'll do this from the Jupyter Notebook. You can do this from any text editor as well, but I'm going to write my new file.txt, 1 on first, 2 on second, 3 on third. I'm going to run that to confirm that I've just created my new file.txt. In this case, I overwrote it because I'd run this more than once. But let's do the following. We'll say with open, and we'll say my new file. And you should be able to actually tab autocomplete this. So my new file.txt, mode, we'll say read only, as f, and then I'm going to print f.read. And there I can see 1 on first, 2 on second, 3 on third. So that's the read mode, which is quite useful for reading. Let's say I wanted to add a new line to this. I could say with open, my new file.txt, I will say mode is equal to, and in this case I'm going to say A because I want to append a new line to this. We'll say as f. And if I want to write to a file, all I have to do is say f dot, and as you may have expected, instead of read, you say write. And let's write a new line to this. We'll say 4 on fourth. So notice what I'm doing here. Because I'm using append, that means the cursor is all the way at the end of this text file, and then it's going to append or add on a 4th line to it. So I'm going to run that, and then let's rerun the code up here. I'm going to copy and paste this to a new cell. And if I run this again, now I see 1 on first, 2 on second, 3 on third, 4 on fourth. Something I didn't actually take into account here is that I forgot to add in a new line. So what I could have done is say \n here to actually insert a new line. So if we run these two cells again, now we see 4 on fourth. Now, unfortunately, I still have this 4 on fourth here, so I'm going to reset everything by coming back up here and overwriting that file one more time. So let's run these again, run this cell again, and then run this cell again. And now I can see 1 on first, 2 on second, 3 on third, 4 on fourth. So that's the difference between reading and appending. Now let's explore W for writing. I can say with open, and here I'm just going to make up a bunch of letters, .txt, and I'll say mode is equal to W. And remember, with this W mode, it's going to overwrite an existing file, or if the file doesn't exist, it will actually create it. So we can make up a name there, say as f, and then say f write. I created this file. Run that, and there's no error. It's because even though this text file doesn't exist, since we opened it with mode W, Python went ahead and created that text file for us. If we had tried to do the same thing with a different mode, such as just R or just A, we would have gotten an error there. So then we'll go ahead and read this file. We'll say with open dhf, and I really encourage you now just to do tab autocomplete, so you don't have to memorize all that. We'll say mode is equal to read as f, and let's print out f.read. And there we can see I created this file. So those are the basic ideas of opening files in either append mode, write mode, or read mode. And you can see a lot more examples of this in your notebook that goes along with this lecture. Okay, thanks everyone, and I'll see you at the next lecture where we actually begin testing you on a lot of the topics that we discussed here. Welcome back everyone. Now that we've gone over the basics about objects and data structures in Python, we're going to have an assessment test to quickly check your understanding. So we're going to do a quick overview of your first test in this lecture, And as a reminder, you can download all the notebooks that go along with this course from GitHub or as a zip file from the course overview lecture. So check out those first couple of lectures. We explain how to get all the information, all the notebooks there. And then you have the option of either downloading the notebook and then answering the questions directly in that notebook, or you can just open up the link and then open up your own notebook locally and answer the questions there. So let's very quickly show you how to do this. I'm going to open the GitHub link right now. Okay, so this is what the GitHub page looks like. We've already shown you this before in the early lectures in this course. Come to Python Object Data Structure Basics, and as a reminder, you can click on here and then download zip to download everything as zip file. You unzip it, you have those notebook files, and then you can use Anaconda Navigator to go to wherever those zip files or those unzipped files were saved. Click on Python Object Data Structure Basics, scroll down here until you get to Assessment Test. Notice there's also a solutions file. In the very next lecture, we'll go through the solutions. So all the tests here that are in notebook form, you can do a self-assessment against the solutions lecture or the solutions notebook. Let's click on that assessment test. And this one's going to be pretty straightforward. Because you don't know a whole lot about Python right now, we can't give you too many technical questions. Later on, as you learn about functions and object-oriented programming, the questions are going to get a lot more technical, and there's going to be kind of a right answer and a wrong answer. But right now, these are pretty basic questions. The first one, I just want you to write a brief description of the following object types and data structures that we've learned about: numbers, string, lists, tuples, and dictionaries. This is really just for you to quickly write down, make sure you understand what the differences between a list and a dictionary are, for example, or the differences between a list and a tuple. So as a reminder, you can click on any cell and then change the cell type to Markdown in case you want to write yourself some notes. Up next, we have just a couple of questions about the numbers lectures. So I want you to write an equation that uses multiplication, division, and exponent, addition, and subtraction that when you put it all together is equal to 100.25. So this is just to make sure that you remember all these arithmetic signs. Should be pretty straightforward. And this is just to test your memory. Again, you can just work backwards from 100.25 to actually grab the numbers that makes that work. Then I want you to answer these three questions without typing any code, and then use code to check your answer. So I want you to see what's the value of this expression, and this expression. So this is testing order of operations, see if you remember that. And then here's an interesting question. What is the actual type? So that's the data type of the result of here. So as a hint, we have an integer being added to a floating point number being added to an integer. So what would the type of that be? Then I want you to find a number's square root as well as its square. So find its square root and then figure out what its square is. So to the power of 2. Okay, then we have strings, and for the given string hello, give an index command that returns the letter E. So you're going to enter your code below right here, so print out E using indexing. Then I want you to reverse the string hello using slicing, so we kind of showed a quick way to do that later on, or earlier in the course I should say. Then given the string hello, give two methods of producing the letter O using indexing. So notice O is the last letter in the string S, so there's two methods of grabbing that last letter. See if you can figure them out using indexing. Then lists, I want you to build the list 0, 0, 0 two separate ways. Go ahead and review the lists lecture to figure out how to quickly build out the list two separate ways. Then I want you to reassign hello in this nested list to say goodbye instead. So using indexing, grab hello and then reassign it to be goodbye. Then I want you to sort this list below, so see if you remember that method call. After that, we have dictionaries. So this one's going to be a little tricky because first off, we start off with just simple grabbing the keys and value pairs. So for this first dictionary, or really all the dictionaries, I want you to grab the string hello. The first one should be pretty basic. You see here you have a simple key, and then you have hello. So it's just D and then simple key, so I kind of gave you the answer for that one. The second one's going to get a little more complicated, so let's zoom in and really look at it here. Notice that we have a dictionary nested inside another dictionary. So you're going to need two calls there. And I recommend that you break this down in steps. Then we have something that's even a little trickier. And just as a quick reminder, these are pretty unrealistic expressions of dictionaries or lists. This is just for you to practice indexing and key calls. So again, try to grab hello from this. And if you're able to do it, then you really understand indexing and lists. And then finally, this is the last one. This is going to be pretty hard and annoying, but just break it down step by step by grabbing keys and then index, key, and then maybe another index, etc., until you get to hello. Then I have a quick little question here that we've probably asked you before. Can you sort a dictionary? Why or why not? Then we have tuples. So what's the major difference between tuples and lists, and how do you create a tuple? Then we have sets. So what is unique about a set? What makes a set different than, say, a dictionary? And then I want you to use a set to find the unique values of the list below. And then finally, we have a section on Booleans, and this is a bonus section, so you don't really need to do this if you don't want to, because it uses comparison operators, which is going to be the very next section of the course. So consider this kind of a bonus section for you to read through, because in the very next section, we're actually going to cover a lot of this. But what we see here are operators. So these are comparison operators, the description of the operator, and then an example of the operator. And I want to see if you can kind of teach yourself what these comparison operators are in order to answer what the outputs are here. And even if you don't really know comparison operators formally in Python, it should be pretty obvious what something like this would be. Is 2 greater than 3 if you've done some basic mathematics before. Again, this is an optional section because we haven't officially gone over comparison operators. We're going to do that in the very next section of the course, so kind of think of this as a bit of a preview before that. Then we have one final question. What is the Boolean output of the cell block below? So again, a bonus question here for you. Okay, so best of luck, and in the very next lecture, we're going to go over the answers for all of this. Again, these are more kind of open-ended questions. Later on in the course, we're going to get a lot more technical in our questions as you learn more. We'll see you at the next lecture for the solutions. Welcome back, everyone. In this lecture, we're going to quickly go over the solutions for the Objects and Data Structures assessment test. So first off, we had that first question which just asks you for a brief description of all the following object types and data structures. We're going to go through that first and then head over to the notebook. So numbers, pretty straightforward. There's basically 2 types of numerical information that we can store. Those are integers for whole numbers, and floating points are numbers of a decimal. Then we have strings, which are an ordered sequence of characters, lists, which are an ordered sequence of objects, and lists are mutable, meaning you can change items that are in a list. Tuples, very similar to lists, except that they're immutable. They're still an ordered sequence of objects themselves. And then dictionaries, those are key value pairings, and remember those are unordered. So now let's hop over to the other questions in the notebook. Alright, here I am at the solutions lecture. Pretty straightforward stuff. We just went over the first question, which was just answering about the data types. Then we have numbers. So all we had to do for this one was write an equation that uses all the various arithmetic methods we just discussed. And your answer is probably different than mine, but all you had to do was use multiplication, division, exponents, addition, and subtraction to somehow get back to 100.25. So a lot of this is just practicing order of operations, and you can just work backwards from 100.25 to make up your equation. All right, so your answer is probably different than mine, but here's an example answer. Then we wanted you to answer these 3 questions without typing any code. So what's the value of this expression, and this one, and this one? This is just to make sure you understand order of operations. So in this one, this first one, we're going to add these together before multiplying. In this one, we're going to multiply these 2 together before adding 5. And in this one, we're going to multiply these together before adding 4. And then the next question, what is the type of the result of the expression 3 plus 1.5 plus 4? So the answer for that one is a floating point number, because once you introduce a floating point number into this equation, it doesn't matter how many integers there are there, we're going to get a floating point number. Now the question, what would you use to find a number's square root as well as its square? So to get a square root, you can just mathematically say something to the power of 0.5 is the square root of the number. Later on, we're going to introduce the math library that will allow you to actually import a math function for doing the square root automatically. But in this case, this is a way to use a clever trick with exponents to get the square root. Then for the square, well, you know that's just asterisk, asterisk, and then 2. Next up were the strings questions. So for this one, given the string hello, we wanted you to list out the index commands to grab the letter E. So in this case, if we just count over from 0, let's zoom in one more level so we can clearly see this here. So 0 is at H, that means E is at 1, so we just had to say S of 1 returns E. Then we wanted to reverse the string hello using slicing. So we showed you this trick, but basically it means go from the beginning all the way to the end in a step size of -1. So a nice little trick there that'll reverse the string. And the reason that it's working is because you're going backwards through the string because your step size is a -1. Then we wanted you to give 2 methods of producing the letter O. So the ways to do that is using S to the negative, or S indexing at -1 to grab the very last letter of that string, or just counting from the beginning up to index 4. So those are 2 different ways of doing that. Then we had lists, And for this one, we wanted you to build the list 0, 0, 0 in two separate ways. So the first way you probably did it is actually the second method listed here, which is just actually constructing the list using square brackets, pretty straightforward. But we also mentioned that you can use multiplication of a single list earlier in the course. So here we have this list 0 multiplied by 3, and now we see it here 3 times. Up next, we wanted you to reassign hello in this nested list to say goodbye instead. And the way you do that is you had to use indexing twice. So here we go 0, 1, 2 to grab the entire list, and then we go 0, 1, 2 to grab hello, and this is why we have 2, 2 reassigning to goodbye, and we get back the result here. After that, we wanted you to sort the list below. So there's different methods you could have done. One method that we showed you was this .sort method, and then you just call the list again. But there's also a built-in function that I want to just introduce to you now, which is called sorted, and that allows you to pass in the list, and this one actually returns the list itself. So notice what's happening here. This .sort method does it in place, meaning you need to call the list again in order to see the results. The sorted function will actually not do this in place, but instead return the sorted version. So that's the difference between using sorted and calling .sort. Moving along, let's talk about dictionaries. So using keys and indexing, grab hello from the following dictionaries. And this starts off simple, but then gets harder and harder. First one, pretty straightforward. You just pass in simple key to get hello. And then the second one, you have two key calls here. So first you do K1, and that brings back this dictionary. And then to get hello from this dictionary, you just say K2. Then this one's getting a little trickier. So first we have to call K1, which brings us back this entire list right here. Then we have to call 0 on that list, because notice, and this is kind of the really tricky part, is that this is a list of one element. So in order to grab that dictionary, you have to call 0 there. So that one's really tough. And then the next one is nest key. So from there, you're just kind of dealing with a normal dictionary. And then you have that list coming out. So we want to grab the second item in that list. And a lot of people get tripped up by this last one. Why is there a 0 there? And that's because, just like before, we have a list of one element there. So if we just want to grab that one string element, we can say 0 and then get back hello. And then finally, the really tough one, which was this is hard and annoying. So this one's a little crazy. And again, don't worry about real life code. Hopefully you never have to deal something with that. And if you do, this is really bad programming, but it's a pretty good question for practice. So what we do here is we say grab the first key, then grab the second item from the list that returns, then grab K2 from that dictionary in here, grab at index 1 this dictionary right here, then we say grab tough, and then we just do some more indexing to finally grab hello. And again, there's a 0 at the end because this is a single item in a list. And what's really useful for you, if you need to kind of break this down and understand it, is just build it out step by step in some cells. So first run this, just d of k1, then run the next step, dk1 with 2, then run the next step, dk1 with 2 of k2, and so on until you get the result. Then can you sort a dictionary? Why or why not? The answer is definitely no, you cannot sort a dictionary because normal dictionaries are mappings and they're not a sequence. And if you're a beginner and you're dealing with really small dictionaries, this definitely isn't clear at first, but I can't stress enough that normal dictionaries are mappings and not a sequence, and they cannot be ordered. Later on, we're going to learn about some special libraries that do allow us to use kind of a dictionary-like object, which is called an order dictionary. But right now, normal dictionaries, you cannot order them or sort them. Then we have tuples. What's the major difference between tuples and lists? Well, tuples, as we learned, are immutable. And how do you create a tuple? Just with parentheses, as shown here. What's unique about a set? The answer is that they don't allow for duplicate items. So kind of a hint there, just with the word unique. And then we wanted you to use a set to find the unique values of the list below. So here you have this list, and then you pass it in through the set, and now we get all the unique elements of that list. Finally, we have Booleans, and we had a little table here for operators. This is a bonus section because basically the very next section of the course is going to discuss comparison operators and logical operators. So you can see here the operators we have. We're going to explain this in a lot more detail in the very next lecture, but you have a description here and then an example. A lot of these are pretty straightforward. This is checking for equality, inequality, greater than, less than, greater than or equal to, and then less than or equal to. So hopefully just by learning that little table there, you can see that 2 is greater than 3, that's false. Is 3 less than or equal to 2? Well, that's false as well. Is 3 equal to 2.0? That's definitely false. And this one's kind of interesting. Is 3.0 equal to 3? Well, that's actually true. So Python, in this case, doesn't actually care that this floating point, and this one was an integer, As long as they hold the same value, it says they're true there. And then finally, is 4 to the power of 0.5 not equal to 2? Well, remember, to the power of 0.5, that's the same as the square root. So 4, square root of 4 is 2, so 2 is equal to 2, meaning the question is 2 not equal to 2 returns false. And then a final question here, also a bonus, what's the Boolean output of the cell block below? Well, let's take a look at it. L1, 2 of 0. So where's that? We have L1. At index 2, 0, 1, 2, we have another list. And then we want 0, so that's 3. So we know L1 right here at these indexings is actually asking for the number 3. So is number 3 greater than or equal to whatever this is? So let's take a look at that. We want 0, 1, 2, so 0, 1, 2 at key 1, so that's 4. So it's asking, is 3 greater than or equal to 4? And we know that's false. So that's the final bonus question. Okay, definitely these questions are a little more open-ended. They're not quite as structured. Later on, we're going to see a lot more structured questions that kind of have more technical right and wrong answers, and you're going to be able to kind of more efficiently program your way through the future tests. Thanks, everyone, and I will see you at the next lecture where we discuss comparison operators and logical operators. We'll see you there.